to you all. Am I audible, sir?
Yes, yes, yes.
So, very good evening to you all. Shri Kumarswami Mahavidyalaya Ausa, District Latur, is organizable record series 2. Today, there is 212th day of the series, and the keynote speaker for today's session is on dais Honorable Dr. Revati Shriram Madam. So first of all, I welcome to you, Madam, for the dais.
Thank you, sir.
I welcome the chief organizer of the series, the principal, Shri Kumarswami Mahavidyalaya Ausa, Honorable Dr. M. Dept, sir. I welcome the colleagues from my college, Dr. Sanjay Kale, sir, Anita Doli, Madam, and others, and heartily welcome all those dear participants. The topic for today's presentation is TRIZ, that is a theory of inventive problems solving. Now this topic is going to present, as I have mentioned, Honorable Dr. Revati Shriram Madam. She is an assistant professor serving at the Department of Instrumentation and Control and from Cummins College of Engineering for Women in Pune. So with this brief introduction, now I request you, Madam, please start your presentation on the topic TRIZ. You are most welcome.
Thank you, sir. Thank you for the introduction. Just give me a second so that I will start sharing my window and we will move ahead with the presentation. Kindly confirm whether you are able to see my screen shared.
Yes, Madam, it's visible.
Okay,
Please continue.
Thank you so much, sir. As sir already said that, I'm Dr. Revati Shriram, and my today's topic for the presentation is TRIZ. It is actually the empirical method for creativity and the innovation. As we know that in today's world, innovation is the very important thing. Without innovation, we cannot feel or felt like what the next few years would be. Today, wherever we are, is because of the innovation carried out by the people who were there few years back. So I will be letting you know about what the TRIZ is and how does a TRIZ is actually applicable to any field and how an innovation can be obtained by using the TRIZ technique. This is the brief overview of my today's presentation. I will be starting with need of the innovation, then I will introduce you all to the TRIZ. Then what are the principles in the TRIZ, the top concepts, where do we actually apply the TRIZ, the predominant fields, and what are the career opportunities if you are going to be TRIZ certified. So that I will be ending my presentation with. So as I pose the first question, why? Why do we need actually the innovation? We know that innovation is important in each and every field because the reasons it gives us edge over the others, like competitive advantage, economic growth, solving complex problems. There was a phone long back in mid-90s also, a telephone. We used to actually go ahead with booking a trunk call to reach to another country and talk to the people from that country. Nowadays, because of the innovation, world has come very closer. Well, we know that we don't need to book the trunk call. We can just carry a small cellular mobile or a phone in our hand, and by just putting an internet call, you can actually talk to the person or your family member who is way away from you. In between, there was a phase when we were used to have still the phone, the actual phone without a cellular phone, and we used to pay with the international calling card. And by using that calling card, we were able to reach that person. So over the years, like maybe around 20 years, a lot of change has happened in this communication technology. How this change was possible, how this innovation was possible. This was possible because of practicing the tricks in the companies who were actually working on it. Like innovation is not just solving the complex problem, but because of that, it actually improves our quality of life. It provides us better healthcare. A very simple example. We do have nowadays a simple automatic BP machine or a glucometer, maybe made by the company like Omron. We do keep it at home. few years back, around 20 years back, what used to happen whenever we used to feel that, gosh, I feel I'm having a bit of a blood pressure raise, or maybe I feel that my sugar level is not correct right now, it might have raised. So we need to take the appointment of the path lab, we need to go over there all the way, get the blood check, and we used to wait for the half day, 12 hours. We used to give the blood in the morning and the reports used to come in the evening. Nowadays, because of the innovation happening in the medical area, we are able to have these handy instruments like automatic BP machine, a glucometer at home, and that too at a very affordable cost. So innovation in each field is actually making our life better, improving it one way or the other, directly or indirectly. That's why it is much needed phenomena in the human being's life. So when we say that we want to have a creativity and the innovation, creativity, thinking differently, thinking out of the box way. Whereas the innovation is actually going to propose that solution by building some hardware or software. Few years back, we used to be very used to the methods like brainstorming sessions. We used to say that this was the problem, we all sat together, we just brainstormed over 4 years, 4 hours, 5 hours, and we were able to get the solution. Or by posing a problem from the lateral thinking, critical thinking way, using the synaptics, or maybe a mind mapping method. Right now, people are very largely using the neuro-linguistic programming, NLP. Wherever you go, you just get to hear this word. I have written an algorithm based on NLP, and I'm talking about these are the emotion extracted from the different whatever the social websites are and stuff like that. So we are very commonly heard these words which are actually mentioned on this slide, which are used for predominantly creativity and innovation. Though all these methods are based on emotion and there is no fixed way by which we can apply them. Whereas I will be talking about TRIZ today, which is an empirical method, and it is not based on emotion, but there is a very fixed way by which you can apply it and can get an innovative solution to the problem which you might be facing. And that problem can be from any area. So this TRIZ, innovative method for problem solving, inventive problem solving, it actually overcomes the psychological inertia. So the psychological inertia is going to be based on our habits, our education, paradigms, internal processes, or the past failures, or maybe the past successes as well. What happens? We generally say that, hey, I know how it can be done because I have done it earlier, right? So I know the proved, tried way. So that is the psychological inertia.
Madam,
But
can you
TRIZ,
speak some louder or keep mic closer because the sound intensity is something less?
okay, are you able to hear now?
Yes, try to speak
Okay.
keeping mic nearer to your mouth.
Yes, that's what I will do now. So when we say that I have already tried it earlier or I have done it earlier, that is a tested way. And once there is a proven tested way, we get used to it and we believe that if I'm going to follow it every time, I will get a success. That is not true. So, to achieve the right innovation in the correct field, you ought to follow a very typical way of applying that particular logic, which will lead you to an innovative solution. So that's what TRIZ helps us to do. So what is this TRIZ? This TRIZ is the acronym used for the for that English sentence, the theory of inventive problem solving. Though the theory of inventive problem solving is an English conversion of a Russian sentence, and TRIZ is the acronym picked up from the Russian sentence. That Russian sentence you will be able to read on the slide. So it is Terorija up to the ZX. I won't try to pronounce the in-between words because my pronunciation of Russian words might go wrong, which I definitely wish to avoid at this particular point. So the Russian sentence is not that important, but what is the English meaning of that sentence? It is the theory of inventive problem solving. So this empirical method, it is not a new method. It is definitely not a new method. It was developed long back in 1946 and was used up to 1985 predominantly in USSR. And it was developed by an engineer and a scientist named Genrikh Eichler. He is the one who used to work in the patent office that time. So as we know that the intellectual property of all these Western countries is very much higher, or they are very much ahead of India in the IP. We are now just emerging into the field of IP. But whereas when we look at how many patents the rest of the countries are having, like maybe Korea, Russia, China, US, UK, that number is way higher than whatever the IP we are having over here in India. So when he was working there in the patent office, while going through all those patents, he realized that there is a typical way of writing that particular patent and conducting the research and reaching to an innovative solution. So this problem solving method is completely based on a logic, available data and research, and what is the existing problem. It doesn't actually say that you should be thinking all the way differently, though it suggests you how you can think in a bit different way, a bit, not completely different way. So what does TRIZ is? TRIZ believes that whatever the problem we are facing currently at this moment, that has already been solved by somebody, somewhere, sometime ago, or whatever, the few years ago. And this creative problem solving involves finding whatever already available the solution is and adapting that particular solution with a modification to our current problem. So it says that you don't have to look for all the way different solution. Look for a similar solution and modify it in such a way that it will be applicable to your existing problem, and you will be able to get rid of whatever the negative points of your product are, and you will be able to get the better product, which can be actually an innovative product. So thus, where do I actually use this TRIZ? A very wide application of TRIZ is in the product development. Those products can be from any field. It can be from chemical industries, it can be from process industries, it can be from medical field, healthcare field, it can be from any other like mechanical related processes or the industries also, in design engineering and in the process management. When we talk about the process management, first thing comes in our mind, it's the Six Sigma, quality improvement process. So Six Sigma word is known to everyone. School going student, maybe of 8th or 9th standard also, he or she also knows that what the Six Sigma is all about. That Six Sigma also often uses this TRIZ technique. Okay. So what this actually TRIZ is all about. As I just mentioned few minutes back that Genrikh Eichler, the scientist or the engineer who invented this particular technique way back in USSR, he was working in the patent office. So while working over there, by analyzing those thousands of patents which came across him, he developed a concept of technical contradiction. Those contradictions can be the technical and physical. So we should be actually paying attention to technical contradictions as well as physical contradictions. And then innovation theories associated with this concept. So to apply that particular innovative way of thinking, he actually formed 39 engineering parameters, 40 inventive principles, 5 basic levels of invention and actually 9 parameters of evolution. In this diagram, you might see that there are 8 written, but later they were actually upgraded to total 9 parameters of evolution. So this is the actual base required for TRIZ, for practicing and applying the TRIZ. So when we say that we wish to actually practice, first we should be able to understand what the TRIZ is. We should be able to apply all these 39 parameters, 40 inventive principles, 5 levels of inventiveness and 9 laws. Then we will be able to actually develop an innovative solution for a particular single problem. But by practicing it over the years and practicing it over the different fields, actually one can get mastery in the TRIZ. Okay, one can become a specialized person in actually applying and using or practicing the TRIZ. So while practicing the TRIZ, the key concepts which one ought to remember are the contradictions, inventive principles, those are the 40 inventive principles, inventive standards, then ideal final result, that is IFR, is very commonly used word in the TRIZ fraternity. Then the TRIZ algorithm, the patterns of evolution, and substance field analysis. So when we talk about the key concept, contradiction, what does that mean? The contradiction in a problem. Generally what happens, we say that if we want to get a particular thing from a particular product, then there is always a trade-off between some properties. That trade-off is like a contradiction over here. Then inventive principles. There are 40 inventive principles specified by Mr. Ashler, and those are actually covering all the possible fields which are around us, which are around each and every human being, so that whichsoever problem we will be facing currently, that can be correlated with at least one of them. At least one, it can have more than one. At least one of the inventive principle which is already available or proposed by Mr. Ashler. Then inventive standards, ideal final result. This is a very important stage because it helps in setting the clear goals for problem solving. So you should be actually doing this ideal final result very properly. Then applying the TRIZ algorithm. Then looking for which pattern of evolution our product fits in and at which level of inventiveness that product falls under. And finally, the substance field analysis. This substance field analysis is actually the tool for breaking down the problems into some small components or the substances to better understand what are the underlying issues in that particular product or that particular problem are currently. So we should be actually knowing all these concepts thoroughly and how each and every concept is actually applied to a particular problem at a particular stage. That has to be practiced. So next comes some key tools from the TRIZ area. So what does the TRIZ says? TRIZ says that there is a generalized problem, and for that generalized problem, already a generalized solution is available. So we need to look for that particular problem as well as its current solution, which is repeated across different processes or the industries. Okay? Because that is the first thing we should be able to find out. Later on, eliminating the contradictions is the important part. And those contradictions can be the technical contradictions or those can be physical contradictions. When we say that a particular contradiction is a technical, that does mean like a trade-off, a classical engineering trade-off. When we say that, hey, I want the product to be good, though I don't want the cost to increase or the weight of that product should not increase. So as we say that I want my mobile to be very good quality camera, very good quality, maybe the sound quality should be good. I should be able to watch movies properly. So the screen should also be infinity screen with a larger screen size. Though I feel that width should not increase, cost should not increase. That is never going to happen. So such a kind of thing is a common way of specifying a technical contradiction. Whereas for the product, there can be a physical contradiction as well. For example, when we are very much in a hurry and we need to just go outside and there is a raining situation, we do carry the umbrella. What happens generally? Because of the optimum size of the umbrella or sometimes a bit smaller, we are going to get wet, a little bit of wet while going out. So we say that, gosh, my umbrella should have been large enough. But still, it should be very handy and small so that I should be able to carry it in the purse. So that is not going to happen, as we know. If I want the umbrella to be larger, the size is also going to be larger and it is going to pose some hindrance while carrying it. So that is a classical example of physical contradiction. So while practicing TRIZ, the first thing we should be able to find out the generalized problem, the problem closer to whatever the problem we are facing with respect to that particular process or a product. Look for a general solution which is already available and then try to eliminate both the types of contradictions. Those can be the technical, physical or both. So when we are talking about this problem solving by this innovative method at TRIZ, the very typical way of process is followed over here, which is shown on this particular slide with an arrowhead. That is much more better way explained on this particular slide. For example, let us say you are having a current problem. So problem you have already analyzed that being in this system, I am facing this particular problem. For that particular specific problem, look for a closer general problem from the 40 inventive principles. At least one general, or you can look for more than one general. When you are able to make sure that this is what the closer general problem for my specific problem, look for what is the solution available for that general problem. Because there will always be a solution already proposed based on whatever is that general solution already available in the domain. Look for how it can be modified or changed to suit it to whatever the specific problem we are facing. And once it has been modified, carry out the evaluation of that modification and the selection. So when we are moving from a specific problem to a general problem, that particular process is the formulation of the problem through the prism of TRIZ, is known as abstraction. So once from that general problem with respect to by referring to the 40 inventive principles, identifying the analogies with the specific and the general problem, and then modifying the general solution to the specific solution, that is again from the analogous solution, it is known as applying or practicing the analogy technique. So this is the base of TRIZ. TRIZ says that you don't have to think completely out of the box. You ought to have some base to take it further, and that base is going to be provided from 40 inventive principles to decide the general problem. Along with these 40 inventive principles, there are 39 parameters which are specified by the TRIZ community or the fraternity. Which are those 39 parameters? On this particular slide, you will be able to see the first 20 parameters. When you look at these 20 parameters at a glance, you will be able to make out that mostly each and every field is getting covered. For example, they are talking about the weight, they are talking about the length, area, volume, speed, force, strength, stability, temperature, energy, illumination, everything. And when you move further with rest of the 19 parameters, you will be able to see about how reliable it is, how much is the time taken, information loss, whether it is easy to repair, how much is the complex control, is there extent of automation possible, is there manufacturing precision. So rest of whatever are the parameters which we can think about for any process, irrespective of that process is coming from which domain, is getting covered under this umbrella of 39 parameters. So we should be able to find out for our own problem which are the things from 39 parameters are applicable. Whether it is with respect to the length, whether it is with respect to the area, whether it is with respect to the weight, whether it is with respect to the complexity, blah, blah, blah. Okay? Remember, you should be able to select the least parameter, but the most accurate one, the most important one. Few parameters, for making it lesser, you can just drop few parameters which are not that important for the product which you are thinking about. The 40 principles of the TRIZ, inventive principles. These principles are shown by the TRIZ fraternity in the form of a pictorial, where you can see that the first row is about the first 8 principles, then followed by the 9 to 16, we come up to the last row, 33 to 40. At each and every pictorial, there is something written in a single or maybe at the most 2 words. For example, the first pictorial says that it is talking about the segmentation, then taking it out, then asymmetry, merging, nesting, anti-weight, that is whether it is getting proportional and whether it is getting balanced, another dimension, oscillations, color changes, stuff like that. So whatever the problem we are trying to solve, we should be able to find out what is exactly closer to that particular problem out of these 40 inventive principles. And once you are able to decide which inventive principle is closer to the problem you are facing, then you should be going in depth with respect to that inventive principle. Because that inventive principle has also been explained stepwise in depth once it has been chosen. So first you should be able to choose the correct inventive principle, and then you should be able to go below subdivided parts of that particular inventive principles to apply it to the current problem. As in the previous slide, those titles of the 40 inventive principles were not that clear to read. So I have just mentioned those titles again over here for a clarity with the corresponding numbering. This slide covers the first 20 principles, whereas the second slide covers the rest of the 20. Hence, 20 plus 20 is a total 40 inventive principles. Moving further, we have seen 39 parameters, 40 inventive principles. Now is the time to discuss 5 levels of inventiveness. The invention which we wish to have can be segregated or decided at which level we are talking about that invention. Whether we are at a very preliminary level, whether we are at the very advanced level, or whether we are at the intermediate level. So that level of inventiveness is also been explained by the TRIZ fraternity. What is the first level? First level is a very basic level of invention. Usually we treat that there is no much or as such invention needed at this particular level. A very simple example, I have jotted it down over here, which says that, okay, we wish to do the writing. So how the writing can be done? As we know that long back in the Stone Age, we used to use the human. In that particular Stone Age, used to use a coal for writing without doing any kind of modification to the coal. Whatsoever the size, the dimension, the piece was, it was simply used for writing. So that was a very basic level of invention. Usually we can treat that as no invention is needed over there kind thing. The second level, we will be doing minor improvement in whatever the existing solution was in the level number 1. For example, let us say in the level number 1, we were using the coal for writing. Now that coal has got a grip of wooden, maybe what we can say a wooden stick. So the coal is getting wrapped by a wooden stick. So we can say that it is no more just a coal, but it is a pencil, a graphite pencil. Doing the same thing of writing, though it is better than coal because it is easy to carry. It is not going to make anything dirty, whichever we are going to place it into, and looks sophisticated also, so that whatever the aspects of how it looks, that also is taken care of in the level number 2. Level number 3, there is a fundamental improvement to an existing system by using the method. For example, pencil, whatever you write by pencil can get erased, can be removed. We want something as a permanent thing. So now no more a graphite or a coal-based pencil, but it will be a ink-based pen. Okay, as we know that the writing cannot be erased. Moving further in the level number 4, a completely new generation of a system, okay, which we wish to have by applying the principle over here. For example, we had a pen. We want to go further. What else? Over here, we can have a printer. We don't have to do the typing. If it is already typed by me or someone else, just by clicking the print button, by hitting that print button, you can actually get the pages and pages printed very easily, right? And they look sophisticated, and what we can say that easy to carry also, and much more data will also be fitted into the smaller size. Whereas the level number 5 is the most sophisticated level of inventiveness. That is the highest level of inventiveness. We feel that no more printer. We don't want to vest the pages. Go green is the technique we actually following or we actually promote. So what is next? Go ahead with the electronic pen and paper. The same thing, right? But we do not have to do the printing. The ink can be saved, the paper can be saved, and go green technique can also be promoted. This way, the level of inventiveness can be thought about for any given problem. Remember, whatsoever is already available currently in any domain is never going to be the highest level of invention. It might be the highest level of invention at this given time instant, though down the few years, definitely someone would think in a different way, in a creative and innovative way, to make that particular existing solution much better than what it is today. So this is not the process which can be stopped at any given point. Now the left out part is the 9 parameters of evolution. So what are those 9 laws or the parameters of the evolution? There are first 3 laws which are completely the static law. So the first law says it is about the system completeness, the second one is the energy conductivity, and the third one is harmonization. Whereas the 4th and 5th law is assumed to be, it is always going to be a true. It is going to be talking about increasing the ideality and the irregularity of the system's part evolution. Whereas the last 3 laws, the 4 laws, the 6, 7, 8 and 9, they are going to be linked with S-curve. This S-curve technique I haven't introduced in this lecture. It is a very important thing. The S-curve is actually going to decide how your innovation is and what is your speed of innovation and how much innovation or IP can be generated with the way you are actually thinking about. I'm not going to go into the details of the S-curve. So the last 4 laws are actually that S-curve. So in all, these static laws plus the always true consideration of those 2 laws and the S-curve laws are the total 9 parameters of the laws applied for the evolution in the TRIZ technique. So what is the algorithm for the problem solving used by the TRIZ? TRIZ proposes that there are 9 steps and one needs to follow all these 9 steps in a sequential manner. The very first step is about defining the problem. For defining that problem, we need to first list down the requirements and the constraints. And after that, once the requirements and the constraints are written, we know what exactly the problem is. What do we want to modify? Where we want the innovation to happen. Once the definition of the problem is done, then comes the part of ideal final result, IFR, where it is going to eliminate the deficiencies. While eliminating the deficiencies, it is definitely going to preserve all the advantages that particular problem is already having. Of course, we do not want to make it more complicated. That has to be taken into consideration. After this stage, the third stage, where we need to determine the differences between the original system and the ideal final result, IFR. Then need to create the ideality equation based on the list of differences as benefits, cost, and the harmfulness. Then find out the contradictions, the technical as well as physical. Some of the products can have only technical contradictions, or some of them can have only physical, or some problems can have both technical as well as physical. So it depends on which kind of problem we wish to actually handle. Then comes the sixth step of the algorithm, which is going to determine the input parameters. At least 2 parameters from 39 parameters listed should be chosen. Okay. Then comes the physical or technical contradiction. Over here, the contradiction matrix is supposed to be presented. It is actually a graphical method of presentation on paper, and you need to plot it, and actually a large sheet, people whosoever is actually practicing or helping or working as a consultant for the companies, as a TRIZ consultant, they sit with a large sheet with this contradiction matrix, with physical and technical contradiction, and which can be taken care of and which we want to actually take further, because they are not going to hamper the final end result. So all that has to be actually done properly on paper. That is taken care of in the step number 7. Then determining the general solutions from the general problem. Of course, that general problem is going to be the problem which is closer to our actual problem, a specific problem. That is done by using the 40 inventive principles, which we have seen just few minutes back. Then the last step, examine the solution. So when you convert that generic solution into a specific, does that solution actually increase the total valuation of that particular product by ways of the features, by ways of whatever the functionality we are proposing, like that? If we feel that no, that is not obtained by whatever the specific solution we have come across, then this is not the solution which we wish to implement on the large scale. Go back to step number 5. Again repeat 5, 6, 7, 8. Find out what modifications you can do and come to a new solution. Then again judge that solution with respect to how ideal it is, from the point of view of the parameters, the features, whatsoever it is, the functionalities. Once you feel that, yes, the new specific solution for the specific problem is way ahead than whatever is already available in the market, and it is going to give edge over the other companies or the competitors, then definitely this is the solution which must be implemented. This is going to be the end point for finding out the innovative solution for that particular problem. The same thing can be explained with the help of flow chart. So over here you will be able to see a bit of a complicated flow chart. Though whatever I said in the previous slide, exactly the same thing is divided in the form of different, what we can say, the logical expressions, and the flow chart has been drawn over here. So I won't go into explaining all the steps over here used in the flow chart. They're exactly based on the algorithm which we have discussed. Moving further, now is the time for the TRIZ tools. So what are these TRIZ tools? Whatever we have seen till now are actually the bits and pieces of the TRIZ tools. So establishing the goal, problem, then selecting the problem, defining the problem, then decomposing whatever that problem is into the subparts, then finding out the selection of the sub-problems key for that particular whatever we are thinking about, then applying the generalized solution or general idea for that problem solving, then developing the idea portfolio, and finally evaluating whatever the idea we have thought about as an innovative idea. This is how the whole path of the TRIZ tools goes, one after the other. Of course, when we just see it as a process or a path, it looks fine. I'll be able to do it easily. It is not that easy to practice. It requires lot of hours, man hours for understanding how a TRIZ can be accurately applied to a very simple problem. And by practicing it every day, one can actually achieve a mastery. Of course, by doing the certifications proposed by the TRIZ Institute, it helps you out in thinking that particular way of empirical thinking method to reach an innovative solution. Now over here you will be able to see some benefits of the TRIZ because it is used for problem solving, that too based on fixed algorithm. Because of based on a fixed algorithm, it is repeatable. Otherwise, when we think about rest of the innovative creative methods which are emotion based, there is no specific way or fixed algorithm. The way I thought this is how it will work, that thought, right? So when we say this, the repeatability of getting the correct, accurate results over the years for different problems reduces. Whereas that doesn't happen with the TRIZ because there is a fixed method, algorithm, which we need to follow one after the other. So this becomes a repetitive method where it can be repeatable. This is the most important benefit of the TRIZ. It is better and more innovative solutions, hence it increases the creditability and it actually helps us in increasing the IPs for our own institute, our own company, or whosoever we are working for. It reduces the number of trial and error based solutions because it doesn't actually just does it on its own like I thought this is how it would be, but it follows the fixed algorithm. Because of that, we are able to save time, money, and totally it reduces the risk. And it works on any type of problem. New product, modification of product, failure prediction, analysis, anything can be done. So it is actually over the years, we can actually keep innovating the same device or the same product by applying a TRIZ. And because of that, a position in the market can still be maintained for a different companies. It is possible. What happened in the telecommunication? For example, we started with a Motorola because they are the one who actually found out the first cellular phone. We thought, wow, such a great invention, a breakthrough invention. Then after few years, we said Nokia is the best one. They are having very good mobiles which are very small, handy. They are giving good battery life. Then they are cost effective, blah blah blah. But when we are in 2023, we don't hear the name Motorola. We don't hear the name Nokia. What happened to them? What happened to these tech giants? They lacked in the innovation with respect to the product they were handling. Whereas Samsung actually went a way ahead because they thought that we can make this mobile a bit larger. Remove the push buttons. Why do we need the push buttons? They are going to get stuck at one time. LCD screen, LED screen itself can work as a push button. So that thought was again came from them. Later on, they thought about infinity screen. Initially, when we used to have mobile few years back, 10 years back, we used to have a top non-usable band and the bottom non-usable band. Only the intermediate screen was the actual working screen. But the infinity screen concept was introduced by Samsung. Samsung is one of the company who widely practices TRIZ, and this solution actually came from practicing the TRIZ in that company. So where do we actually apply? Which are the areas we apply the TRIZ in? So the application fields of TRIZ, it is very widely used in businesses, marketing, quality management, value engineering, research and development of all the tech giants and the innovation. Over here, instead of specifying a particular company name, I have just generalized the fields of application. Okay? So when you are thinking about a field, just remember any field from any domain, mechanical, civil, chemical, healthcare, instrumentation, whatsoever, the computer, IT, all these sectors, everywhere TRIZ is used and practiced. This slide shows just what I can say, at a glance, which are the companies which practice TRIZ. So just try to look at the slide and you will be able to see that, gosh, all these companies I do know, but we never thought that they might be using the TRIZ. To start with, Decathlon, ICICI Bank, GlaxoSmith, Nestle, Tata, Google, L'Oreal, Procter & Gamble, Honeywell, Hilti, Texas Instruments, Boeing, what not? Everybody is using it. Please remember, these are not the only companies which are practicing or using the TRIZ. There are a lot more. Whatever the logos I was able to fit into this single slide, I have picked them up. Okay? Otherwise, there are a lot more companies. The countries which show that they are having a very good IP, the patent filing and granting rate, all those countries practice TRIZ very widely. TRIZ has been taught to them from the school and college level itself. That's why innovative thinking has been actually enhanced in those students from the school and college days. Moving further. As I earlier also said that there is a certification. One cannot just say that I can use TRIZ or I can practice TRIZ. One needs to complete the certification levels of TRIZ. The certification levels of the TRIZ can be completed from the TRIZ actual institute of the TRIZ, the international one, and they give the matrix named certificates. There are total 5 levels. Whereas in Asia, TRIZ Asia is the company which actually helps you out in completing the TRIZ certification. Again, there are also 5 levels, the same. Both the, whatever the institutes are, they go exactly in the similar way for completing the certification. The first 3 levels are for the user category, and these, once the person is level 1 certified, level 2 certified or level 3 TRIZ certified, that reflects the degree of TRIZ knowledge that person is carrying. I am having only level 1 TRIZ certification. Specialist category is level 4 and 5. This reflects the effectiveness of candidates' activities in the field of the TRIZ. To actually get all these 5 levels of TRIZ certification, we need to put into the efforts of 4 to 5 years at least. It is not like that if I start today, I will be able to complete all these levels within few months. That's how the levels are actually decided. The certification is granted based on how many inventions you have done in the level number 4 and 5. Then only you can move from one level to the other. And in the initial levels, the total hours which we need to put into completing that certification itself is very much higher. And trust me, the exams are ultra difficult, but they are fun to attempt. fun to attempt. But a bit dissatisfactory part is that the cost involved in this certification is very high. You can just go and check these websites and you will be able to get idea about how much is the costing for level 1 TRIZ certification. That is one of the things which actually makes us go away from completing the further TRIZ certifications. If someone is more interested in finding out what this TRIZ is all about, then these are some of the references which can be used. The TRIZ Principles book written by Jenry Cashler, the ISBN is mentioned over here. The second one is Dennis the Inventor. It is the book written by Gandhi Inawal. Again, the ISBN is written over here. And of course, if you don't want to get hold of these books, a lot of data is already available on the internet, so just Google it and you will be able to get hold of the data. But for practicing it, a certification is must. With this, I would like to thank all of you for your patience and giving me an opportunity to present the topic TRIZ today in front of you. Thank you so much.
Thank you very much, madam, for wonderful presentation on the topic, the term TRIZ. Now I request all the participants, please, if you have any query, come ahead and ask to madam, dear participants.
Thank you everyone. Thank you Gayatri ma'am. Thank you Uday sir. Thank you Harendra sir. I must thank
Ma'am, from where we can get the TRIZ certification?
as we are staying in India, it is better to actually go ahead with TRIZ Asia. TRIZ Asia is the www.trizasia.com is the website, and Mr. Shri is the person who is the owner of that particular institute in India. It is placed in Mumbai. And you will be able to see the schedule for the different levels, and whatsoever their schedule is, one needs to follow that schedule. So please do visit the website trizasia.com. Yes, sir. Please go ahead.
So thank you, Chaitanya
Hello.
madam.
Hello.
Yes, Swanand sir.
Welcome, sir. Swanand Shukla, sir.
Yes, sir. Good evening, Dr. Betkar, sir, Principal, sir, Prashant, sir, and thank you very much, madam, to elaboratively explaining the trees. And it is a very much related with inventive, and I think it has started with USSR first. And yes, definitely the progress is very important. Like what you have given a wonderful example, like Motorola and then other companies, Samsung has proceeded to, given better facilities, and we are moving further and further. So I think it is a kind of spiral what we are talking about. So it is wonderful thing. Even for the medicine
Bola,
field
madam.
also, we are going with the super refined medicines and other things. So
Bola
definitely the topic is very much concerned with us also. So thank you very much, madam, for your great presentation. Thank
छान
you.
झाला वाढदिवस
Thank you,
तुमचा.
sir.
बरोबर टाकतो. बरोबर
Thank you, Dr. Swanand Shukla, sir.
2 मिनिटात टाकतो. हं?
Now I request the Honorable Principal, sir, with the Chief Organizer of the series, please come ahead and have some words for today's session. Please welcome.
Thank you, Prashant sir. Today's resource person, Revati Shriram madam, daily participating and taking interest in discussion, Dr. Swanand Shukla sir, my colleague Sanjay Kale sir, Dohle madam, and all the participants, those who are joining here daily, including Chaitanya madam. If we see the market or any leading organization, that organization should do innovation by surveying the stakeholders. So in last but few slide, madam have shown a slide which it was a bunch of leading companies, those who are leading in market and having a reputation in that, and they all are using TRIZ. So this research innovation factor on different levels, how it is utilized in our education or any factory or any startup or any leading business, it is helpful to have progressiveness in that performance. As the company, those who are not using TRIZ, or why they lagged behind in the market, because of the not studying all the trends or the uh, reply from the stakeholders or the users. So those who are innovatively doing all these things, they are in the market and they are in leading. So this type of TRIZ, which madam have said, scientifically it is proved that it is useful, and those industries or those are using this, they are ahead in the market. Thank you madam, this was so much technical session but useful to all and informative to all. Thank you madam.
Thank you, sir. Thank you so much. Thank you, everyone. Good night.
Just wait for formal vote of thanks by the organizer.
Okay.
So thank you very much, sir. Now I move towards the vote of thanks. Shri Kumarswami Mahavidyalaya Ausa, District Latur in Maharashtra. We all know that organizing our record series 2. Today we have completed 212 days of the series, and the topic for today's presentation was very essential for those all companies, industries, etc. The term TRIZ, which have been explained by Honorable Dr. Revati, very sincerely in a detailed way. At the beginning, she explained why the innovation is needed. Then the invention is life in different methods of creativity and innovations. Then the introduction of the TRIZ. Then the key concept tools in TRIZ. How does the TRIZ stands for? The different applications, fields of the TRIZ. Then the 40 principles of the TRIZ, 39 parameters of the TRIZ, and how to use applied TRIZ. Now each and every points we have covered in our lectures. Really we have justice to the topic, madam. Even though this is a new term, but we explain in detail in a simple way. We could understand a lot from your lecture today. So I'm very, very thankful to you. You have paid your valuable time to the series. So thanks once again. Really it was a very wonderful session. We appreciated a lot from your lecture. Thank you very much. Then I thank to the chief organizer of the series, Honorable Principal M.M. Betkar sir. I thank the colleagues from my college, Dr. Sanjay Kale sir, Dr. Anita Dorle madam, Praveen Kamble sir, Honorable Praveen Utge sir, and all others. On the screens, I am saying that Chetna madam, Mausmi Paul madam, Dr. Harendra Singh, and all participants. Really they join every day to the series and always encourage us. So thanks to you all. And at last, I should not forget all my dear participants.
Thank you madam.
Who joins regularly. So thanks everyone once again. Now I request you all please fill the feedback link which is given in the chat box. So with the kind permission of the chief organizer, I declare that today's session is over. Thank you very much, Revati madam, once again. You come again with new topics because this is a new term. We not around about the TRIZ, etc. And you explain it very sincerely. So once again, thanks a lot to you, madam. Please.
Thank you, Prashant sir. Thank you, Betkar sir.
Thank
With
you,
this,
madam.
I will take your leave. Thank you.
Thank you.
Yes, madam.
Prashant sir, thank you. Every time you recognize me with this honor and you fill me with new energy. And thanks
We
to
are
you.
proud of you, madam.
Officially
The
recognized.
participants like you. We are proud of you.
बोला
Ladies,
टाकलो रे मी, बघ की दिसले नाहीत का?